Solutions to assignment questions. Before we start, let me remind you to finish your corrections before the next lesson. Question 37 to 45. So you have to rethink the last question. When the layer of air is very thin, would it change the angle in glass? Now you can see we apply the Snell's law twice. Here we have eta water equals sine x over sine 38. Next, we apply the Snell's law again between air and glass in this way. Eta glass equals sine 54.97 degrees over sine y. And now, from these two equations, we can see for the first layer, water, we have eta water multiplied with the angle in water, sine 38, equals to that of the third layer, glass, eta glass, sine y. In other words, the layer in the middle, which is air, is not important. And that's why our answer is no, it does not affect the angle in glass. Copy down these lines in red if you are asked to do corrections. Question 38. This question you may apply the question directly. There's no layer of air, but there is only water and glass only. And so we apply the question like eta of water times sine the angle in water equals eta of glass multiplied with sine the angle of glass. So remember to use your calculator to find the answer for the angle x for your corrections. Question 39. This is a similar question. And now we have the refractive index of water, eta water, 1.33 multiplied with sine y equals to the refractive index of glass, 1.5 multiplied with the angle here, 30 degrees, right? So sine 30. So use your calculator to find the answer for y in your corrections. Question 40. In this question, you can see there are 4 layers, but you don't have to apply the question 3 different times. You don't have to, because for each layer, the product of the refractive index and the sine value of the angle will be equal to that of the next layer. What I mean is, for the first layer, diamond, you have the refractive index 2.42, and then for the angle 21 degrees, take the sine value, sine 21 degrees. Multiply them together, that will equal to that for the glass layer, that is 1.5 multiplied with the sine of the angle x. And in this way, you may carry on for the next layer, 1.33 multiplied with sine of the angle y. And that go on equals to 1 multiplied with the sine of the angle z. By calculator, you may know that the value of sine 21 degrees multiplied with 2.42 is actually 0.86725. And in this way, by looking at the very last part of the equation, you can see we may calculate the angle z directly. Easy, actually. Question 41. In this question, you have to draw a ray diagram to illustrate the situation. There's a similar diagram in your book which looks like this. Well, but you can see the image position is not correct. In our diagram, the image of the polar bear goes to the left, while for the ray diagram that you find in your book, the image is on the right of the object. So you have to flip the ray diagram in this way, so that the image is now on the left of the object. Question 42. Before we talk about the solutions for the next few questions, let me remind you the following. Number 1. When light ray travels between air and glass or water, then the angle between the light ray and the normal, this one, must be larger than the other. So make sure you have a larger angle in air than in glass or in water. Secondly, in order to locate the image, you must draw two light rays. So when the observer eye is here, you must have two light rays. Yes, two. At least two light rays. And to locate the image, you have to produce the light ray backwards, like this. 1 and 2, and they intersect at this point. And this is the image position. Now we are going to use these techniques to find the image position of the following cases. So there is light ray that comes from the cone. We have to draw two light rays, and they refract on the water surface. They refract on the water surface. And as I said, the angle they make with the normal is bigger in air than that in water. Next, we have to produce the light ray backward so as to find the image position. Question 43. It's quite a similar question. Now you have to find the image of the floor of this swimming pool. These are two light rays that come from the bottom of the swimming pool. And the two light rays reflects on the water surface. Again, these two light rays bend away from normal. They make a larger angle in air than in water. And so the image position is, we produce them backward. And so this becomes the image of the bottom of the swimming pool. And that's why the swimming pool looks like to be shallower. Question 44. The situation is a bit different now because there is a water tank. There is light ray that come from the fish. And these light rays also bend away from normal so that they make a larger angle in air than they make in water. Now for the observer, he will believe that the light ray come from this point, the intersection point. And so the image of the fish is here. And so the fish looks like to be closer. Question 45. Now it is the fish that sees the boy. And so light rays should come from the boy. And now you can see the light rays make a bigger angle in air again, but a smaller angle in water. We say that the light ray bends towards the normal. So for the observer, which is the fish will believe that the light ray come from this point at the back. And so the image of the boy is at the back. Make sure you finish your corrections before the next lesson.